Okay, so 6.3 is all about logarithms. And I'm sure you've heard of logarithms before somewhere, but we're going to start at the very beginning of this. So we always like to start with talking about exponents. So 2 to the power of 2 is 4. And then we also have, 2 to the power of 3 is 8. So that leaves us with the question, 2 to the power of what is equal to 6? Because if 2 to the power of 2 is 4, and 2 to the power of 3 is 8, there has to be a number in there that we can raise 2 to the power of to get 6. It has to exist. We just have to figure out how to get there. Well, if we grabbed our calculators, we might start a little bit of guess and checking, and maybe we want something like, 2.5. That makes sense. 2 to the power of 2.5, because it's right in between 2 and 3. And if you plug that into your calculator, you get about 5.657. All right, close, not quite. All right, now let's try, 2.6 and see where we're at with that one. So we plug this into our calculator, and we get 6.063. A lot closer on that one. We are almost there. So here's the whole deal, is that if you actually need to go ahead and find this number, we in math phrase it as this: 2 to the power of x is equal to 6. Or we're going to go ahead and we're now have this operation called logarithm, and we would say log base 2 of 6 is equal to this number. And if you put that in your calculator, we're going to get to that in a different section, but if you went ahead and did it, we would get that x is equal to 2.585 about, and that would give us a number 2 to the power of 2.585 about gets us 6. I, of course, rounded on that one. All right, so let's go ahead, let's define this logarithm. So logarithm, oops, I forgot my I. Logarithm is defined as if we have b to the power of x is equal to y. Then we know, so if and only if, log base b of y is equal to x. And I also like to put it in this other form to help you out. Switch to a different color pink here. So we talk about our base to our exponent is equal to our answer. And if we change that into logarithm form, we keep the same base. So log base of our answer is equal to our exponent. And I'm going to highlight these to show you where all of these numbers go. So let's start with our base. So log base, those stay the same, but now we have is an answer, and we're going to take of our answer is, of course, equal to our exponent, this answer. So it's now just a different form, and I'm going to show you this in class, but the big aha moment are that logs are inverse functions or inverse operations. I'm going to put operations of exponents. And I'm sorry to take away that big aha moment from you because it's a video, but I promise to show you in class is that it is the inverse operation. Just like how we undo multiplication with division, we undo exponentials with logs, and we undo logarithms with exponents. It works back and forth. So let's throw a few examples here. Just getting in the habit of changing these around. So my first example here is that we're going to change from exponential form to our logarithm, and I have 4 for you. So 5 to the power of x is equal to 25. Excuse me, take that back. 5 to the power, I'm going to go ahead and give you numbers for all these because we know what they are. 5 to the power of 2 is equal to 25. 10 to the power of negative 1 is equal to 0.1. 8 to the power of 2/3 is equal to 4. And 6 to the power of negative 3 is equal to 1/216. Okay, so those are all the exponential forms. We're going to change into logarithmic form. So we're going to change our form. All right, so it just takes practice with these, and of course looking at what's your exponent, what's your answer, and what's your base. So for this first one, we have log base 5, bases stay the same, of 25 is equal to 2. All right, for our next one, we have log base 10 of 0.1, I'm going to put that in parentheses so you can see there, is equal to negative 1. It's equal to that exponent. Log base 8 of 4 is equal to 2/3. And then our last one here, log base 6 of 1/216 is equal to negative 3. So changing from logarithm to exponential, changing from exponential to logarithm form. And for example 2, I'm going to ask you to change from logarithm to exponential. So we're going to start with log base y of x is equal to c. Then we're going to do log base 4 of 2 is equal to 1/2. And log base 2 of 32 is equal to 5. All right, so once again, we're going to change, and this time we're changing to exponential form. All right, so bases stay the same. So y is the base. Now to the power of c is equal to x. For our next one, 4 to the power of 1/2 is equal to 2. And that's definitely true there. The power of 1/2 is the square root. So 4 to the power of 1/2 is equal to 2. And this last one, 2 to the power of 5 is equal to 32. And once again, that is true. 2 to the power of 5 is equal to 32. So hopefully that you can see is that you can actually solve some of these logarithms without using a calculator. So for example 3, I'm going to ask you to solve this one, and we're going to say, what is log base 3 of 81? So as a reminder here, logarithm is an operation. Just like how multiplying, dividing is an operation, so is now log. What this is really asking is, this is saying, okay, 3 to what power is equal to 81? And we're looking for that question mark there, right? What power? Well, we know 3 to the power of 4 is equal to 81. So log base 3 of 81 is equal to 4. And we can see that we can solve these. Actually, I've already used that. Let's switch back here. Let's try another one. Example 4. Okay, we have log base 3 of 3. All right, this is really asking 3 to what power is 3? Well, 3 to the power of 1 is equal to 3. And again, if you need to see that in exponential form, that's what it's asking there. 3 to what power is equal to 3? And for one more that we can solve together, and again, you can solve these without a calculator right now. Don't need that calculator. We'll get to a calculator later on in this unit. So a little bit harder on this one. This is asking for log base 5 of 1/625. So again, putting it just kind of in this form, we're saying 5 to what power is equal to 1/625. And if you need to break this up a little bit more, you could possibly see here that 1 over 625 can also be written as 1 over 5 to the 4th. But it's negative because you need to go ahead and bring this up to the denominator. So this is 5 to the negative 4th is equal to 1 over 625, aka log base 5 over 1 of 1 over 625 is equal to negative 4. And that's how you go ahead and you solve logarithms, that you think about them as an exponent. So just a few notes here is that you're going to run into two specific types of logarithms. So the first one is what we call common log. So common log, it's what your calculator uses, and common log is log base 10. And we write this simply as just log. So it's what your calculator uses. So what we're going to say is the log button on your calculator. So for example, on this one, if you had something like log 100, even though it doesn't have a base written there, what it actually means is log base 10 of 100, which is really asking, okay, 10 to what power is equal to 100? Well, we know that's 2. So if you don't see a base next to a log, you can assume that it's base 10. The other thing that you need to know is your natural log. And we write this is actually your log base E, or what you'll see as ln. And this is called our natural log. And this is the ln button on your calculator. And we've actually used this before. It should be associated with that E because it is log base E. So for example here, if you have ln E, what this actually means is log base E of E. Well, we know that E is a number. It's 2.72 approximately. So go ahead and say E to the power of what gives you E? Well, we know that that's 1. E to the power of 1 gives you E. And we can go ahead and solve those. So those are the logarithm basics. We're going to go ahead, I'm going to give you two a little bit more difficult example problems. So I'm going to go ahead and call these challenge examples. So stick with me, and if you have questions on them, I'm happy to answer in class. I'm going to start with example 6, and I'm going to say f of x, or a function, is equal to 6 to the power of x plus 1. And what I would like to know is I'd like to know the inverse of f of x. What's the inverse of it? Well, we quickly went over this at the beginning of this, is that the inverse operation of exponentials are logarithms. So let's go ahead and walk through these steps of finding your inverse function. First of all, switch your f of x with y, and then switch your x and y. So x is equal to 6 to the power of y plus 1. Now we need to use these inverse operations. So I'm going to try and isolate, I'm solving for y, so I'm isolating it as much as I can. X minus 1 is equal to 6 to the power of y. And at this point we might get stuck. But we now have this inverse operation, is that we can say log is the inverse ops of exponentials. So just like how, again, multiplication has an inverse operation of division, addition has an inverse operation of subtraction, this is how you undo it. You take the inverse of it. So we're going to switch this into logarithm form. Well, we're going to say log base 6, and then I take my answer. So then I'm going to take x minus 1, I'm going to isolate that exponent, is equal to y. And there you have it. We isolated y, and this is our inverse of it. So we get log base 6 x minus 1. And if you don't trust me on this one, feel free to go ahead and head to Desmos and check out those two functions on a graph. They're pretty cool. Last one for the day, example 7. And again, these are challenge examples, so just stick with me. And of course, if you have questions, please circle them so that we can make sure that we are reviewing anything in class. All right, so again, I'm going to give you a function g of x is equal to the natural log of x plus 3. And I want the inverse of g. So I want g's inverse. What is this? Switch it to y so that you can say y is equal to natural log of x plus 3. And again, switch your x and y's. First easy steps of solving for your inverse. Okay, now you need to start to go ahead and isolate y. Well, I can isolate y here. I don't know how to do this natural log, but I know that the inverse operation, here we go. Inverse operation of this natural log is an exponential. So in order to undo that, I have to switch to exponential form. So exponential form, let's say change to. Okay, so we have the natural log. This really means log base e of y plus 3. Okay, so now we can say e to the power of x, because this is our exponent if this is in log form. So base exponent answer is equal to y plus 3, and now we can isolate y by subtracting 3. So we get e to the power of x is equal to, e to the power of x minus 3 is equal to y. And here we have it again, one more time, is that this is now our inverse function. And again, if you'd like to go ahead and throw this on a graph, you might get some ahas and go for it. All right, ladies and gentlemen, I will see you very soon. Those are logarithms.